Here we're given a random sample of the high temperatures in 7 small towns. And we're told that high temperatures are normally distributed, and we want to find an 80% confidence interval. The first thing we have to do is choose our distribution. Since sigma is not known, we're going to use a t-distribution, and we can do that because we're told the original population is normally distributed, so this asterisk here is satisfied. And when we use a t-distribution later on, our degrees of freedom will be 6 because it's 1 less than the sample size. So I'm going to show you 2 ways to do this. The first way is by far the easiest, and it's just using the LibreText calculator. And I'll put a link to the calculators in this problem and also in the module. So here's what that page looks like. And you're going to click on confidence interval for mean with data. And then if I go up here and copy my numbers and then paste them over here, I just have to put commas in between, then enter the confidence level, which is 0.8, and hit calculate. And this problem wants accurate to 2 decimal places. So to 2 decimal places, our 80% confidence interval is 97.81, comma, 99.19. And that's it. That's all you have to do. Now, if you want to use formulas to solve this problem, then you are going to need this is method 2, by the way, you're going to need the sample standard deviation, which is recorded right there, 1.2956, and you would have to enter these numbers into a one variable stats calculator to find the sample standard deviation and the sample mean, which is 98.5. And then we need to find t sub alpha over 2 because the error bound is t sub alpha over 2 times s over the square root of n. Alpha in this case is 0.8. So when I compute 1 minus the confidence level and divide by 2, I get 0.1. So what that means is this is t sub alpha over 2. The area in this tail is 0.1. And so the area over here is 0.9. So I'm going to find t sub alpha over 2 using Desmos. What you're going to do is click on functions. I'll move this over and go down to distributions and pick inverse CDF. Then go back to functions, go back to distributions and pick the t distribution. Enter the degrees of freedom, 6. That's 1 less than the sample size. And then comma, we need to enter the area to the left of t sub alpha over 2. So that would be 0.9. And we get, to 4 decimals, this is 1.4398. So back over here, I've already recorded t sub alpha over 2. And so when I compute my error bound, I take t sub alpha over 2, multiply by s, divide by root 7, and I get about 0.7051. And then I construct my confidence interval by adding and subtracting that number respectively to the sample mean. So when I do that, so this is adding and subtracting to the sample mean, and I get this confidence interval, which agrees to 1 decimal with what I had before. And there's a slight discrepancy over here with my previous answer, but it's well within the acceptable bounds. And so that's a second way to do the problem.